Welcome to J-Scale Models. I'm Jason, your host. I do models. Today we're going to be looking at my Siglent SDL1020EX 200 watt DC electronic load. I've had this for a little over a week. I'd say about 8 days, maybe 6, somewhere around there. And I haven't got to use it yet because I don't have the cables I want for it yet, and they haven't come in yet because I'm going to make my own cables. So I just rigged up this little test to mess around with this battery pack and try not to blow this up. This is an Anker Power Core 5000. This is a battery pack, 3 lights, power. It says it's got IQ technology. What is it? It says it can take up to 2 amps, but it can output 2 amps at 5 volts. So 5,000 milliamp hour, so 5 amp hour. So we're going to see if we can put a load across these very sketchy wires. Very sketchy wires. Let me show you how sketchy those wires are. Very sketchy. So this could all go bad. So I have it set for 100 milliamps. But first I want to check this. Well, first we'll do it in constant current, and we'll draw 100 milliamps, and it seems to be fine. The battery voltage dropped to 4.982 volts. So we can set that current here, go to 200 milliamps, that was fine, 300 milliamps, 400, nothing feels like it's getting hot, 500. So that's all I want to draw through these super crappy wires, but I want to turn that off, and I want to check out this, is it auxiliary? And then you can go into battery, and then you can have constant current mode. Current, let's change my ranges from 30 amps to 5 amps, and voltage from 156 volts to 36 volts. And then we will come in here and we will do 0.150, enter, 150 milliamps, and check page 2 is, we can tell it when to stop, or when the time stops. So let's say voltage stop on at 0 volts, because it's going to show up. Current stop 0, and then I'll leave time stop off. So let's turn this on here, and if we draw 100 milliamp, battery test complete. Okay, maybe we should not turn those on, so let's turn those off. Okay, let's try this now. Okay, so now we are running the timer there, and we can draw this battery down and see how much it actually produces. Because before, when I would test battery cells, I would use one of these. Sorry for reaching over the camera and knocking that camera. I would use one of these USB meters that basically show you the current being charged into them. You plug these. You plug these in from your charging source, and then you plug in the USB port, and it'll log how many milliamp hours you put into the cell. But that is putting it in at 3.7 volts. So because it steps the voltage down to 3.7 volts, because that's what the battery voltage is. So it has to, in order to get power back out, it needs to put it out at 5 volts. So what I plan on doing is fully discharging this with the electronic load when I get less sketchy wires. And after it's fully discharged, it shuts itself off with its protection, make sure the protection works. I will then in turn charge it up with either the charging capabilities of my Siglent SPD3303xe power supply, as it has a feature to do that, so I might charge it up with that, or one of these USBs, or both, to see how accurate these are. And then I will discharge this through the electronic load at 1 amp and see how much I get back out comparative to what I put in, because there is going to be loss from stepping up from 3.7 volts to the 5 volts, and it could be 4.2 volts depending on how they charge the lithium cell, but between 3.2 and 4.2 volts is the lithium cell. So I want to see what the voltage loss is, because on a project that I'm working on, I want to tuck a battery cell into a scale model I have, but I don't, and I want it to last a while, and I'm hoping that if I seal it up in there and maybe put a charging port on there, I can just recharge it when need be. But I want to make sure I'm getting the most use out of it, and I'm going to be testing all the circuits to draw the least amount of current as possible and have the least amount of standby current, so I can get the most out of one of the little cells that I can, tuck away into like the hull of the ship or whatnot. So that is my goal. So first of all, I'm going to test it with this, because I know that this is a good brand. I use these brand power supplies. I've tested them before. They're durable. They don't overheat too much. I mean, any battery discharged rapidly will overheat, but they seem to have good protection circuits and stuff, so I like this Anchor brand. But the batteries I plan on using for the project are cheap eBay lithium batteries, so I want to know their performance capabilities and test their charge circuits and things like that before I go shoving them into a plastic model that will melt if it catches on fire. So that is basically it for this video. I am going to discharge this. I am going to change the amperage to, what does it say? Oh, I have to turn off the load to change the current. Okay, well then I am going to turn off the load. Turn off the load. And I want to discharge it at 750 milliamps. Do you want to clean up the community? Oh, I cleared it. I was hoping it wouldn't clear it. Okay, so C add 11 milliamp hours. Okay, so I can just add up how much I took out of it. Alright, that makes sense. So if I have to do this in stages, then I can do that. I know that this this DC load can draw, I believe it's to 10 or 30 amps, but like I said, these wires are very sketchy. It's very thin. It's barely making a connection on the terminals. So I don't want to put any kind of heavy load draw through those wires. So I'm just going to sit here and watch it at 750 milliamps and see if this goes flat and if everything shuts off, and just see what I get, because believe it or not, this has been charged for almost a year unused, and it still had 3 lights on it, so it was fully charged to its 500 milliamp hour, and it wasn't used. It was just sitting in storage for a year, for a better part of a year. I mean, it was, if not a full year, it was like August or September of last year is when I got this and fully charged it. And I use these for when hurricanes hit and the power goes out, and I haven't used this one for that. I've used some of my other bigger ones if we had power outages, and this has just been sitting there, so I'm kind of curious to see how many milliamp hours are in this. So if it seems to be taking too long, because it's just ticking up a milliamp hour every 4 or 5 seconds, 5,000 milliamp hours is going to be a lot. I'll crank it up, and maybe I have to wait for my better cables or whatnot. We'll see. That's going to do it, guys. Thank you so much for watching. Here's links. Patreon, support me on GoFundMe. Thank you very much. Have a fantastic